This video is an alternative way of actuating a motor using a light-dependent resistor, LDR. In a previous video on this channel, light-dependent resistor with servo motor and Arduino, I showed how to do this with the Arduino microcontroller and the servo motor. A link to this video should appear now, I hope. The application is a grow tray, like this one, which is a light canopy that will turn off during daylight and also move out of the way to allow sunlight. The application was inspired by one of my project students, Dennis Galushka, who successfully achieved this objective, as can be seen in this clip. Hi Dennis, well done. My alternative methods use a DC motor and hardware only, without using a microcontroller, which in my view is a more robust and in the long run cheaper solution, and also more fun. This is the experimental setup. This is a magnet attached to a rotating arm which is mounted on a motor. These are the reed switches 180 degrees apart. Here is the circuit board. This is it operating. To start with, the arm is in the daylight position. When we cover the LDRs, it is now dark, so the dark side of the circuit is activated. The arm rotates 180 degrees. The magnet activates the reed switch on the dark side of the circuit and turns off the motor. We remove the covers from the LDRs, we have daylight again. So the light side of the circuit is activated. Again, the arm rotates 180 degrees and the magnet activates the reed switch on the light side of the circuit and turns off the motor. So now the light canopy is rotated away from the grow tray. This is a diagram of the canopy arm attached to a motor. As the magnet rotates around, it will activate the reed switches for dark or light conditions as appropriate. Okay, so let's look at this circuit in a bit more detail. We have a light activated side and a dark activated side, activated by the light dependent resistor here and here. So the light side, when it's bright, it turns on the motor. The dark side, when it's dark, it turns on the motor as well. So what we do is the light side activates the motor, but when the arm reaches a certain point, as we showed in the previous video, the magnet engages with this reed switch and turns off the light circuit and stays in that position. Then when it gets dark, the dark side activates and turns on the motor until the magnet comes right around back to its previous position. Magnet activates that reed switch and turns off the motor. We look in a bit more detail of how the actual circuit works when we look at the circuit diagram. So now we'll have a little short video demo. So here we're going to activate the light side. Motor goes on, and when we bring the magnet close to the reed switch, it turns it back off again. Now we activate the dark side. So we cover this LDR, and again, when the arm with the magnet goes near the reed switch here, on the other side it turns it off. Here we have the circuit diagram. The pointer is a bit small, but it is pink, so I hope you can follow it. We have the light side and the dark side. When it's dark, the light side is inactive. When it's dark, the light side is inactive. Let's suppose it is dark. In the demo shown earlier, I cover both LDRs with pen caps. So now I remove both pen caps. What happens? The light side of the circuit becomes active. In other words, this transistor turns on, which allows current to flow through the motor, through the collector, emitter of the transistor, and then through the normally closed reed switch. The motor rotates the arm until the magnet on the arm comes close to the normally closed reed switch, which now opens, so no current passes through it, and the motor switches off. And the arm will stay in the light position until we activate the dark side of the circuit. If I now cover both LDRs, the transistor here on the light side is off, and so has no effect on the motor. The dark side of the circuit becomes active, and these two transistors on the dark side switch on, and the current flows through the motor, through the collector emitter of this transistor, and through the normally closed reed switch here. The arm on the motor swings around at 180 degrees until the magnet on the arm comes close to this reed switch and opens the circuit again, so the motor stops and the arm remains in the light position. And so on through light and dark cycles, moving the arm through 180 degrees each time. Or in the real device, the light canopy moves through 180 degrees. This single transistor on the light side is taking voltage and current from the voltage divider circuit that is the LDR R1 and the 2.2K R2. If you click on the notification that should appear, you can see a detailed explanation of how this voltage divider circuit works. To recap, we can see in light conditions the resistance of the LDR R1 drops considerably and we get V out of around 2.5 volts, which is more than the 0.7 we need to switch on the transistor. Also, we get sufficient current to the base of the transistor to turn it on, in this case around 1 or 2 milliamps. To fully switch on the transistor, we need a voltage of greater than 0.7 volts and a minimum current around 1 milliamp. And this is why we need two transistors on the dark side. On the dark side, the voltage divider is switched around, so we get V out of 4.7 when it is dark, which is enough to activate this first transistor. However, as the current has to pass through the large resistance R1 of 22K, the current to the base of the first transistor is not big enough to fully turn on the transistor. In this case, it is around 0.2 milliamps, well below the 1 or 2 milliamps I need. So the current flow through the first transistor from collector to the emitter is directed towards the base of the second transistor. Initially this was around 33 milliamps, and that's why I have a resistor of 10 ohms so that the current is not too large. Now the second transistor is fully turned on and allows sufficient current to pass through the motor and turn it on. This arrangement is known as the Darlington pair. Now, full disclosure, as they say. I'm an electronics hobbyist, and my knowledge is by trial, mostly error and experiments, and whatever I can get from various Google searches. So if some of what I have said is inaccurate, forgive me. In conclusion, it would seem that the activation of the Canopy arm using the Arduino and servo motor as implemented by Dennis is simpler and less cumbersome. However, the solution presented here does have its merits. Most of the electronic components only cost a few cents, whereas Arduino costs around €20, and DC motors tend to be cheaper than servo motors. In a real-life application, the canopy and grow tray would be much bigger, and so the power required to move the canopy arm would be much greater. Arduino can only supply 5 volts and small currents, so a relay circuit would have to be incorporated to drive our larger motor. On this last screen, I've shown links again to the two videos mentioned previously.